Hi everyone, welcome to grade 10 trigonometry. I'm just going to challenge you to get a paper, a ruler, and probably a protractor, and a calculator. We're gonna have some fun here from where we left in grade 9. So please get that. And what I want you to start off with is to construct a triangle, okay? A triangle, then some triangles within that triangle. So let us start with this. First of all, you're gonna construct a big triangle. So there's my line. I've tried to be quite accurate this time around. So, oh, what am I doing there now? Okay, yeah, so I was supposed to do this. And there's my other line, and then there's my third line. So I've got my first triangle up. Then the next thing that you're gonna do to construct the remaining triangles is just to draw a vertical line from really any point on the hypotenuse, just as long as the point is perpendicular to the base of the triangle. I hope you know what perpendicular means. You're gonna do the same thing here, okay? Do the same thing there. And then what do we have here? As a matter of fact, let me ask, how many triangles do we have then? Right? I hope you didn't say one. So I'm now gonna label my points. It's conventional in maths that we label points. And remember, a point in a triangle is known as a vertex, okay? Or in a 2D shape, actually. This is from, again, that topic of 2D shapes. If you thought you are done with 2D shapes, please think otherwise, because you're still going to encounter those in grade 10. You will be calculating good stuff from area to surface area and stuff. So you can see I'm labeling my triangle now. I have ABC, and then I'm now labeling the next point, which is K, and the next point, which is L, and then the next point, I'll call this M, maybe, yeah, let me call that M, and then I'll call this N, right? So there are my points, or rather my lines. And remember, I told you, I asked for a favor that please make sure that those lines are perpendicular. There I am indicating that they are perpendicular to my base. I hope you can see that. Just this little feature that I saw. I'm trying to get better at this thing so that you can see things as you are supposed to. Now, what I want you to do really for me at this point is to measure the following lengths, okay? So let me write this down, okay? Measure, so that you can see, measure the following lengths or sides, whichever way you'd like to say that. First of all, you're gonna measure for me AC, okay? You then gonna measure for me BC, okay? That's one. So in triangle ABC, okay, the big triangle, you're gonna measure AC, which is the hypotenuse, and you're gonna measure BC, okay? That's what you're gonna do first of all right? Then as you measure that, put your measurements down, okay? So maybe you want to do something like this. Put your measurements down. Okay, what did you measure? You can use centimeters or millimeters, not a big deal with me, but I'm sure you the ruler that you have is either centimeters or millimeters. Just be sure you use the same units for that. Okay, in the next triangle, that is KLC, I want you again to do the same thing. Find for me KC, the hypotenuse of that triangle. After you do that, then you also find this, so the length of the side LC. Measure that also. And then finally, in the last triangle, I want you to measure for me the side MC, Minister of Ceremony, Master of Ceremony, whatever that is, Master in Charge, whichever way you look at it, and of course, NC. you will realize you are measuring essentially the same sides, okay? I want you to do that quickly as you can, and then you're gonna tell me what you have observed there, okay? Once you have done that, the next thing that you're gonna do, you're gonna take a protractor. I told you you should get a protractor, and you're going to measure this angle down here for me. Let's call this angle theta, okay? Let's call it angle theta. Theta is a Greek word, okay? For those of you who might be hearing this for the first time, it's a Greek word, and actually it's a symbol. It's actually a name of a Greek letter, rather. So it's not just a Greek word; it's a name of a Greek letter. And in mathematics, we use a lot of Greek letters. And next time you'll hear me saying now alpha instead of saying theta. So obviously alpha means A, and then you'll hear me saying now omega, which is used a lot in physics. Also, there it is, which is the last word in the last alphabet in Greek. Next time you hear me saying gamma, there is delta, which is like D. So there's quite a lot of this Greek letters or Greek alphabets that we will be using in trigonometry, but theta is very much common. Now I want you to measure that angle, okay? I want you to measure that angle. After measuring that angle, you are now going to do this little thing for me. You're going to create a table, okay? And I'm going to put this table in red, somewhere in the middle of my page here, or within this triangle. It's fine. So you're gonna tell me what the size of the angle is. Okay, so angle theta, what you have measured for angle theta, and you're gonna tell me the ratio of each side. In other words, you're gonna tell me now what is BC over AC. Okay, that's the first thing that you're gonna report. Okay, BC over AC is equal to what? And what is the angle here that you have measured? Obviously, the angle will essentially be the same. You're also gonna tell me here's the interesting one. I said you're starting with what? BC over what? AC, right? Now, I want you to also try what? I'm sure you can guess this. Obviously, LC, yes, over KC. You got that right. And what is the last one that you're going to try in relation to the angle? Yes, that is obviously SC, or should I say excuse me, not SC, MC over RC. Okay, what is that equal to? And what is that equal to? And what is the angle theta? On the triangle that you just drew, a similar sketch like the one that I'm doing. Try that. Once you have tried that, we're going to have the last activity for exploration. And once we have done that, then we will talk more about trigonometry. Hope you enjoyed the exercise. Cheers.